Today we are going to talk about data structures, which are very important concept for you to be a very good programmer. Before we get into data structures, let's quickly recap what variables are. Variables are I've shown some variables here. A is equal to 1, which shows an integer variable. Name is equal to Meena, which shows a string. Age is equal to 10, it's an integer again. And letter as A, it's a character variable. Marks is 91.5, it's a floating point variable. Assumption is equal to true, it's a Boolean variable. So these are some of the different types of variables. These are available in most of the programming languages. Some of the concepts which I am going to talk about here are not specific to one programming language. It could be there for one or more programming languages. As you know, these variables occupy a memory location. So A is equal to 1. When we do that assignment, what happens is that 1 is stored in a memory location. When you rewrite that by saying A is equal to 2, that memory location gets overwritten by 2. It's a good idea to have a good understanding about how do you name your variables. Most often I have seen the students giving the names which are just alphabets like A, B, C, D, etc. Your programs are going to be read by someone else in the future. So it could be maintaining it, or it could be for expanding it, or you might leave the organization so someone else might take over. So there could be different situations where your programs are taken by someone else. So pay attention to how do you give your variable names. There should not be any spaces in the variable names. I hope you understand some of these basic things about how do we give variable names. What do I mean by giving meaningful variable names? If we say we want to add 5 numbers and then get the sum, most often in the interviews I've seen the students writing S is equal to A plus B plus C plus D plus E. So S is not meaningful. So later on when someone else use S, maybe 10 or 15 lines later, it will be difficult for you to recall what S stands for. S could stand for something else as well. It need not be sum all the time, right? So it's better that we always represent that with a good name. So similarly, if you want to get the total number of students in a class, instead of just saying students as 100, it's a good idea to say total underscore students as 100. Giving an underscore to these variable names, instead of giving them together, it would make it more readable. So readability is one of the important consideration when you write programs. Moving on to the next topic or the important topic for today is what are these data structures. When we have more than one variable or value or number, so most often it is always the case. So that is how the real life is. So we never say a number without an association with something. Examples of this are, we might want to write marks of 100 students in a class, or we might be asked to write the names of all the people who are standing in a reservation queue, or we might have situation where we might want to store the names of people in a family tree. Yes, we can write those names in any fashion, but we have to remember we have to retrieve it later in the exact same fashion how we have written. Or sometime we might want to store information related to each student. Or a program might be written about storing the number of COVID patients in different cities. Let's take every example and then see what is the appropriate data structure for them. Marks of 100 students in a class. So you all may be familiar with it. We store this in an array. So array is where we store 23 and 24 is stored in the adjacent location to 23. So they are all contiguous together. So it is easy for us to access this information. How do we get the names of people waiting in a reservation queue? So this is also stored in an array, but functionality wise, we cannot just pull some person in the middle of the queue and then give a ticket, right? So we have to always make sure that the person who is standing in the front is getting the ticket. So this kind of data structures are called FIFO data structures. First in, first out. That means the person who first came and stood in front of the reservation counter is the one who is going to get the ticket. How do we store a family tree? So there are these parents, and if you want to get all the ancestors of one of them, so how do we traverse this tree and then get that information? We can just store it in any manner, but it might take us a long time for us to form or get the results for this list of ancestors. So we have to have a representation which is using which it is easier for us to get the results. Some data structures like tree, as beginners you don't really have to bother too much about trees. We don't use it always. So get familiar with basic data structures like arrays, linked list, etc. And then once you are familiar with it, you can go and understand some of these more complex data structures. And in our day-to-day use, we might not be using trees a lot. Another important categorization or the way we would store information is related to an object. For example, if you want to know what are the different characteristics or the attributes of one student, we might want to put all of them together instead of writing as John's age and John's roll number, John's address, etc. The moment we talk about one student, all of this information we should be able to retrieve together. So this is the reason we use data structures like objects or structures for storing information related to students. How do we store information for number of COVID patients in a city? So if there are several cities, we might want to store them as a key value pair. So we would say that Mumbai is 20, Delhi is 20, etc. So we can use a data structure called dictionary for storing that information. Yeah, so I mentioned earlier this data structures for student. We can use objects or structure in C language, but objects have much more information than just these attributes. I will talk more about objects as we go along. But once you are familiar with some of these basic data structures, I will talk about objects in a separate class. Now, why do we need these data structures? We want to make sure that this information are stored together so that we can retrieve them easily. It makes a lot more easier for us to write programs. And obviously, since it's easier for us to store, it is easier for us to retrieve, which will lead to better performance. Again, there are more advantages of using data structures. Once you are familiar with it, we can come back, we can revisit the data structures one more time maybe at a language level. So for each of the languages, There are different data structures, so it would be beneficial for you if you look at data structure for each language. So what I covered so far is at a very general level, conceptual level. It's not related to any particular language. Some of the exercise you might consider doing it is, number one, what's the use of an array? We talked about an array. What's the use? So can you think about other examples? What is a 2D array? There's this concept for 2D array. You don't have to write any programs, but just think about what is a 2D array. Are there any uses of 2D arrays in the real life world? And what are the linked lists? So I have not covered linked list, but this is like a homework exercise for you. Think about what are linked lists and what is the difference between linked list and other data structures like arrays. In the next class, I will cover some of this for you. Thank you.